Alright, slip ring day. Making a slip ring for the fourth axis on a CNC that I am designing and making. So that's the electric slip ring. That's the bearing surface. That's the outer ring. And then rotate around. Those are some mounting holes, pneumatic fittings, and then the pass-through holes for the electric wires. I ended up only drilling one of the pass-through holes, just because it took so long, and that is what we are doing in the video right now. Cut away, you can see some of the internal pneumatic flow passages there, the O-rings, and the radial grooves for the air to pass through. See the shaft that's going to get welded on. The reason it's beveled is that's weld bevel. I ended up making pilot diameter slash pin length longer than was shown in the model, just to help keep everything aligned. Video drilling those pass-through holes that are about to show up in the CAD. There we go. So there's two 7/8 pass-through holes. Due to the length, I had to keep changing back and forth drill bits, sizes, to be able to drill that length. It's 8 inches long, so it's quite the hole. And then I just gave up on the second one because it took me hours to just do this one. So that's what you get when you have less than optimal tools for the job. Yeah, this is still switching back and forth in between drill bits, using the extensions, stepping through the sizes. This was tedious. Very, very tedious. The max speed for this is probably gonna be about 45 RPMs, and then the max pressure is like 100, 120 psi in the air. So if you ever design your own slip ring and it's going to be spinning a lot faster, technically you're supposed to put the seals on the outer ring instead of on the shaft, because centrifugal forces could contribute to making them not seal. So this is drilling the final 7/8 all the way through. Basically have, can't remember the drill size, but a few sizes less than 7/8 all the way through, and then finishing that with the 7/8 drill bit. I was going past the drill flutes, So I had to remove some of the chips at the bottom with a magnet in order to continue wheeling drilling. But we got it done. Getting it aligned on the lathe after the hole drill. Squaring up the end face, prepping for the hole that's going to be drilled for the 1.5-inch shaft. Kind of just took one pass to clean up some of the outer roundness of the stock material. Probably could have saved those for later. Starting to drill that pilot hole for the 1.5-inch shaft. The pilot hole is going to be a 1/2 inch. And then I ended up going one, I think 1.5 inches deep instead of the CAD, which was like 0.5 deep. And that was just to help. I'm about to weld that shaft on there, and that was to help just keep everything straight. We go starting with a 1.5/8 round stock bar. We'll be turning it down to have a 1/2 inch shaft that has a 45-degree taper up to the 1.5/8. I was starting on the outer ring. This could all be done on the lathe, but figured I have a mill and it can do this while I'm working, so they hogged out some of the material for me. to finish up that shaft and taper and pilot and test fit. It's golden. And then I welded it off camera. Don't have a setup to videotape welding. But basically filled in all that beveled area with weld as best I could. The pass-through hole, there was a little bit of material. It wasn't a perfect weld just because it wasn't any material to weld to in that area. And this is truing up the shaft to the rest of the body. It was surprisingly close, but definitely a good portion of the 5/8 extra, or the 1/8 of an inch extra raw stock over what was desired definitely was needed. A bit of a test fit here. I think it was a little tight, and so then I think I took off another 2 thou. It went on, but it was a little stiff. Now doing the diameter for the 100mm bearing that this will set in. And part of the reason for the design of like the pneumatic and the electric slip ring, and you could theoretically put them all on one side. The reason I chose the pass through was that the slip rings up to like 1.5 inches are pretty cheap-ish. But if you started trying to get a slip ring for like a 4-inch diameter, they started getting very expensive. So while the pass-through hole took a while to drill, it did save some money. And the same in general with pneumatic slip rings. You can buy pneumatic slip rings. The issue is just that they are more expensive as you get into these bigger sizes. And desire for the 100mm bearing was a driving factor. So here, making the O-ring groove and the snap ring grooves, had to turn up the lathe speed. It was my first time trying to make a groove like this. I don't think I perfected it, but definitely turning up the speed, using lots of lubricant helped. We got it done, but it probably wasn't as pretty as it could have been. Due to my not great abilities of grooving, I basically did a lot of sanding, or did some sanding to kind of buff the surface, and I got down kind of into the O-ring grooves a bit, try and help smooth out some of those bottom surfaces that those O-rings are going to be sealing on. Did cover the waves with paper towels, keep any of that abrasive off the waves. Here we're drilling the holes for the pneumatics, for the air to go through. These are the ones that are going from the outside towards the center of the part. 3D printed a jig to rest the part on to keep things somewhat square. Cleaning up the back surface that was in the jaws. This is a non-critical surface. Created a jig to drill all the holes that are getting drilled at the end of the slip ring. Right now, drilling the holes for the long air passages that connect to the holes that we drilled from the outside towards the center. This was kind of a nerve-wracking part, just because they're about 3 or 4 inches deep, and they've got to line up and connect. Thankfully, and if they don't, everything's ruined basically. So, but everything did line up, and it all worked out. Had to use a broken off drill bit as a handle of the vice grip. Starting on the outer ring that was hogged out of raw stock on the lathe, or on the mill. You could do it on the lathe. It just, like I said, it was more of an efficiency thing to do it on the mill while I was doing other things on the lathe. Basically getting the final diameters on the lathe. The outer diameter is not critical, so focused a lot on the inner diameter. Did the inner diameter on one clamp, and then did the outer diameter on 2. That's why you see that discoloration there. Drilling the NPT holes on the outer ring. tapping those 1/4 inch NPT. Honing the inner ID of the ring. This is a engine cylinder hone that I hooked up to the drill press and started honing that internal ID. Drilling the mounting holes for the slip ring. This gets mounted to a plate with 4 1/2 inch fasteners. Had the snap rings on there just for test fit earlier and hadn't taken them off. So, final assembly. Starting to look like a thing. So it starts with a snap ring. And then 6 O-rings. Three O-rings. 4 O-rings. 5 O-rings. And 6 O-rings. Now just starting to grease up all the O-rings. Use kind of a thick grease. Hopefully it'll stay where it should be more than a thin grease. And then try to stay out of the flow passages for the air. Test fit of the outer ring. Slipped on like it was meant to be. With a little, tap. You gotta tap it a little bit. Starting to do some pressure testing. See if all the hard work is paying off. That was a flow. The first test was a flow test. Now is the pressure test. Didn't hear any leaks. Now setting it up to rotate under pressure. if I wanted to fix the higher torque or reduce the torque, could go back and machine some of those O-ring grooves, but getting everything lined back up on the lathe would have been a pain in the butt, so kind of just rolled with it. Testing the other side, and everything works. And with the exception of a little bit higher torque than I wanted, this project came out pretty well. It's my first ever slip ring. It was a fun project, a lot of lathe work, which is always fun. And yeah, hopefully this helps anyone who's thinking about needing a custom slip ring, or maybe this is just a fun machining video to watch as someone who has very limited amount of machine tools tries to make a complex assembly. Thank you for watching.